Good evening. My name is Catherine Bruce, and I'm the Executive Director at Planet in Focus. Tonight, I have the extreme pleasure of welcoming you to this live conversation with Planet in Focus international eco-hero Janine Benyus and writer Catherine Osborne as part of the 22nd annual Planet in Focus International Environmental Film Festival, which is streaming nationally until October 24th. To begin, we would like to acknowledge that here in Toronto, the festival is taking place on the treaty territory of the Mississaugas of New Credit and the traditional territory of the Haudenosaunee, the Anishinaabe, and the Huron-Wendat. We're extremely grateful to have the opportunity to work in the community. I'd also like to acknowledge our funders who've been very critical during this difficult past 18 months. The Canada Council for the Arts, the Ontario Arts Council, the Toronto Arts Council, the Government of Ontario, Ontario Creates, Heritage Canada, and Telefilm Canada for their ongoing support of our festival, as well as TD Friends of the Environment for their very generous contribution to our year-round educational programs. Tonight, we're excited to be honoring Biomimicry co-founder Janine Benyus as our 2021 International Eco-Hero. I'd like to also mention that our other eco-heroes this year are Cree artist Kent Monkman as our Canadian eco-hero, and Inuk creator Sheena Novalinga, who has been honored with our Rob Stewart Youth Eco-Hero Award. We're extremely grateful to Azure Canada for their generous support of our Planet in Focus Eco-Hero Awards. And it's my great pleasure now to introduce Alex Miller, founder and president of Azure Canada, and the chair of the Planet in Focus Foundation Board, to say a few words and introduce Janine. Thanks so much.
Well, thank you very much, Catherine. And it's a pleasure to be here to give out this Eco-Hero Award to Janine Benyus. So each year, Planet in Focus honors exceptional individuals who have made a difference in raising awareness of our environment through their actions and their body of work, especially in visual arts and film, but also in written material and their actions. Planet in Focus Eco-Heroes are agents of change, and we honor their spirit and their dedication to their work, and particularly their ability to inspire us. Few people embody this more than this year's International Eco-Hero, Janine Benyus. We're honoring Janine for her incredible work as a biologist, a global innovator, and a writer, and for her ongoing inspiring advocacy and her leadership promoting biomimicry and design for a better world. Janine's a biologist. She's an innovation consultant who's made an incredible difference in the world of design, author of 6 books, including Biomimicry, Innovation Inspired by Nature, published in 1997. In biomimicry, she named this emerging discipline that emulates nature's designs and processes. For example, solar cells that mimic leaves, or concrete that mimic shellfish, to create a healthy and more sustainable planet. Since the book's 1997 release, Janine has involved the practice of biomimicry, introducing innovators to the 3.8 billion years of brilliant time-tested solutions that nature has gifted us. In 1998, Janine founded Biomimicry 3.8, the world's leading nature-inspired innovation and training firm. B3.8's mission is to help change makers transform the world by emulating nature's designs and its core principles. In 2006, she founded the Biomimicry Institute. It's a nonprofit organization that empowers people to create nature-inspired solutions for keeping our planet healthy. Biomimicry Institute also runs design challenges. With a global network of over 9,500 members. In 2014, B3.8, they established the Biomimicry Center at Arizona State University, a research and education facility. So a bit about Janine. Over the past 18 years, she's personally introduced millions to the idea of biomimicry, including me, through TED Talks, hundreds of conference keynotes, a dozen documentaries, and many others, including one of our former eco-heroes, David Suzuki's Nature of Things. She's received numerous awards, including the 2015 Edward O. Wilson Biodiversity Technology Pioneer Award, Time Magazine's Hero for the Planet Award, and the Rachel Carson Environmental Ethics Award, and many more. Almost two, but they're too numerous to mention. Her work's been featured in many magazines. In 2010, Business Week named Janine as one of the world's most influential designers. In 2012, she received the Smithsonian Institute's Cooper Hewitt National Design Mind Award for visionary work with a paradigm-shifting effect on the world of design. So tonight, she's Planet in Focus's international eco-hero. And on behalf of my colleagues at Planet in Focus and at Esri Canada, it's my great pleasure to award Janine our International Eco-Hero Award. So Janine, over to you for a few words.
Thank you, Alex. Thank you for that beautiful introduction. I'm honored to accept this award and all the others that you mentioned on behalf of the tens of thousands of biomimics worldwide, people who are learning to be nature's apprentices. And so I'm especially honored that the Planet in Focus organization is an organization of storytellers and is recognizing our work in telling the story of life and how life learned to live here and create conditions conducive to life. And it's been my honor to tell that story. So thank you for the award.
Well, thank you for being with us tonight. And I'm going to turn things over to Catherine Osborne, who is going to interview you.
Okay, I think I am now live. Nice to see you, Janine.
Good to see you, Catherine.
Thank you for joining us. Just a quick introduction to me, because our paths have overlapped in some sort of way, because I'm in the architecture and design world. I was the former editor of Azure magazine. I still live in that world. I'm no longer with the publication, but I'm working still with architects and designers. And I remember the evolution of biomimicry kind of creeping into these worlds of design and architecture in a very quiet way. And one of the first articles we wrote about biomimicry was really answering that question: what is biomimicry? Like, what is it?
Yeah.
And it was sort of one of those words that we understood inherently, but didn't really understand the depth of what it meant, I guess. So we explored that. And so I thought Alex gave a great introduction to you. Your credentials are like top to bottom, left to right. You've got them all. So we're talking to the right person here about biomimicry. But just to give the listeners a little quick sort of homework lesson, or like a little synopsis of what biomimicry is. It's basically mimicking. I'm just going to give a very non-professional, I guess, description of it. It is what it sounds like. It's mimicking biology. So it's got a lovely self-explanation within its own word. I love that about it. Basically, it's looking to nature to find solutions that we haven't been able to figure out ourselves. So if we were to sort of say, what is biomimicry? It is this idea of nature's, which generally has a much superior knowledge and history to understand engineering, and how do we tap into that to create human-made objects and systems that will be more efficient and more sustainable. So we're deriving our science from what has come before us. So I love that about biomimicry. There's a poetry to it as well as a science. And one of my favorite is the artificial limb that sort of used the elephant trunk as a way to sort of find a 360 way to manipulate an arm or a leg, and that, to go back to nature to find a way to solve that particular problem. But I'm giving a very rudimentary foundation to that term, and the concept goes much deeper. And I know that because you have written 6 books about it. So it's, and you're also coming out with another book. This is a very rich and it's just a very rich topic that has many permutations and many ways in which it can sort of manifest itself. But I want to go back to your first book. I'm going to start the interview now. I guess my first question when I was invited to interview you, I looked back at your biography, and 1997, I was working at Azure, and that's around the time that I was sort of getting familiar with this expression or wondering about it, which is actually 24 years ago, which is
Wow.
century.
Yeah.
Yeah.
Yes. 1997 is when the book came out. Yeah.
Yeah. So, and that book brought the concept of biomimicry to a much larger audience because you used a language that people could relate to. And that's where its permutation kind of started to take hold, I think. It took it out of the science brainy thinking and brought it into sort of a language that could be applied to other things. In my case,
Thank you. Yeah, I mean, that's, that's my job as a science writer, I think.
I think so.
To describe things in ways that, paint pictures and for people. And I'm not afraid to use poetry in science. I'm not afraid. I think that if you're writing about the natural world, you might as well write aesthetically because it is a beautiful and amazing thing. My job really is to increase people's admiration, respect for the natural world, and then their curiosity about how can we mimic this? How can we emulate this? Right. So thank you for saying that.
And the value of that, right? We look to the past, to what they did, what's been done before we arrived. So nature is definitely that map. Yeah. But I want to go back because it was 25 years, it's a nice benchmark to sort of go, okay, let's be a little reflective here. What's different now when you wrote that book?
Yeah.
Where we are now?
Oh my gosh, that's a great question. It's people's now willingness to not just entertain this idea, but realize that, yeah, this is the solution we've been looking for. Literally, it's, I kind of think of myself as the queen of the obvious, that, there's this library of solutions, 3.8 billion years in the making, this R&D, incredible R&D that, enhanced the planet rather than degraded the planet. And I think what's happening now is people are realizing, as we face the emergencies of our own making, that it's time to figure out how to enhance the planet. And that we're not the first species to have to have figured this out. 99.9% of all species that have been on Earth are extinct. The ones that are with us now have figured out how to meet their needs, how to build their materials and build housing and get the food they need and take care of their kids, but in the process, actually cleaning the air, cleaning the soil, or building the soil, cleaning water, in the process, sort of literally this enhancement of the place rather than degrading it. So as what's happening now, you see back 24 years ago, when I was, moving this into corporate America, it was because we would go in as consultants, as biologists at the design table to consult with engineering firms or, create non-toxic materials with chemists, with architecture firms. And it was unusual, very unusual. And there was a lot of convincing that had to be done. It was very difficult to find the money to bring in these biologists. We were pulling a new chair up to the design table, right? And a biologist was sitting there. And what back then, the only biologists in corporate America, in most places except for life sciences, were the ones figuring out how to clean up the pollution that had been done, right? So they were trying to figure, they were meeting EPA guidelines. That's what they had biologists for. So the idea that you would swim upstream in the design process and have a biologist at the conception of a product or process so that you didn't have to have pollution at the end was new. So we were constantly answering the question, bio what? What is it? Why should I entertain it? Now, I think it's the meme has turned into a movement, essentially. And a lot of people in the design and engineering and architecture and the people who make our world have heard about it.
Mm-hmm.
And that's what's really, really different. Both the fact that we realize we need some counsel, some wise counsel. And it doesn't seem like such a wild idea anymore to people. It actually makes a lot of sense to people now. So we've changed as a culture.
And if possible, and I know this is probably an impossible question, but have there been points where you're like, COVID's been kind of a moment of clarity, but along the way, have there been moments where you've seen kind of a shift happen that you can pinpoint and go, okay, that is a moment where the world is starting to, or a significant portion of the world is starting to really come around to the idea that, humans are not, the masters of the universe. The masters of the universe, we're walking on it.
Yeah.
And we need to look down or up or whatever and see what's going on around us. Like, have there been any seminal moments when that shift you have identified as being moments?
I think there were a series of shocks that happened to our psyches as we realized that we were now such a huge geologic force on the planet. And so you look around and it could have been, a really intense hurricane season, right? That we were able to say, this is now climate change. The understanding of climate change, right? The understanding way back then was when we were first starting to realize we created a hole in the ozone layer, remember? Yes. So I think there were these moments where we realized, oh my God, this is the Anthropocene, it's no longer the Holocene. We're now like that big a force on the planet. And it was no one time, but it was a series of shocks that had to do with environmental damage that was not localized, but that was global in nature. And then, as we realized we were double glazing the planet, I think there was also a lot of, I watched as toxicity of our products went from being, oh, well, we have to have that for, like that's just part of it, to people saying, no, I don't want this in or near my body or in or near my baby's body, right? I think, as we began to understand holistic wellness, right? And as customers began to demand that that things be safe, right? And now they're starting to say, let's let them be safe, let them be circular. I don't want to have a lot of waste. I think we evolve, the sustainability movement got broader and broader in its scope. But so were health and wellness, right? So there are these parallel, I think, strands of us expecting more of our designs. I think that's the evolution, is that, and you work with designers and architects, and 24 years ago, it was just the beginning of, maybe you make a building more energy efficient, right?
Yeah.
Now, it's, no, you got to do that plus have operable windows for health and wellness, plus, right? Plus it's got to be adaptable, so you don't have as much construction. We keep expanding our scope and asking more of our designs, and multifunctional. And that's another thing that biomimicry, you know, all these adaptations we talk about in the natural world are multifunctional. And as we started to ask ourselves that things be safe and life enhancing, life friendly, from the chemistry of how it's made to how it's manufactured, you know, how the chemistry of it, the manufacture of it, distribution of it, right? We just kept on asking more and more of, you know, let's make this good for life.
Yeah.
And so that expectation of ourselves has allowed people to start to go, well, where are we going to find the models? And boom, you know, here's biomimicry. So it was like a 24-year overnight success, basically. It was there when people needed it.
It was a slow.
Yep.
It was a slow evolution. I mean, not really in the whole scope of things, but in our lifetime, it's such a, you know, why didn't we accept it back then so readily, and why are we now? But I think people need evidence, even more evidence than, you know, most people. Like, we have to see, you know, New Orleans go underwater. We need to see Miami start to get, you know, soft and squishy, like, in order for us to go, okay, yeah, maybe there is something to this climate change. And we need evidence in order for us to sort of begin, you know, I'm speaking sort of, you know, collectively, to begin to think about alternatives. But, you know, one of the things that I find interesting, okay, here's a question for you. Can biomimicry solve some of the biggest environmental problems we face? Is this going to fix the damage we've done, or stop it, or slow it down? How do you feel about that?
When we're talking about how do we make things, how do we feed ourselves, how do we build, how, you know, those questions, how do we create economies that work like ecosystems? There's always a place in the natural world to go for solving those functions. You know, it's not going to solve moral dilemmas or ethical dilemmas, but in terms of technologies, which is just another word for tools for living, there are answers there. So if you look at something like, all of a sudden, carbon dioxide began to build up in our atmosphere. And for years and years, when I give talks, I've been saying, we're the, you know, in the rest of the natural world, because we are nature, in the rest of the natural world, carbon dioxide is not seen as a poison. It's seen as a building block. So carbon dioxide is what, you know, what plants use to make our planet. And then it's also dissolved carbon dioxide is even what, you know, shellfish use, and what to make a concrete like substance, or corals use. So it was amazing to me that nobody had looked at how life takes, I shouldn't say nobody, because I was tracking the scientists who were looking at it, you know, people who were saying, okay, what is the chemistry of CO2 made into stuff, made into materials? And believe it or not, you know, that was really hard chemistry for us to mimic. But now you see that all the time. I mean, if you buy a Dell computer, the plastic packaging is made out of greenhouse gases, you know, and IKEA is going to do all of their any plastic they have in the next few years is going to be transitioned over into from CO2. So CO2 is just carbon. We found, life found a way to put it into plastic, and, you know, polymers, which are just carbon chains. And so now we're finally mimicking that. And then on even hard things, like our biggest building material is concrete. 7% of our CO2 emissions is in the making of concrete. And now we've figured out how to take CO2. And there's a company called Blue Planet and Calera. They're taking CO2 out of smokestacks, and they're combining it with brine, water that has like water coming out of a desalination plant that has a lot of salts in it, a lot of minerals. And what they're using is the recipe that coral reefs use. All of CO2, a bunch of minerals, and it out precipitates the raw materials for concrete, for road aggregate. So if you go to San Francisco Airport right now, the new addition at San Francisco Airport, all the rock and aggregate it's basically mineralized CO2. So as we're starting to now try to, I mean, that's really, really big. And, in terms of a problem statement, water, every cell in living things has these little hourglass shaped pores. They're called aquaporins, and they escort water through the pore in the cell, and they leave other things behind, the solutes behind. It's called forward osmosis. What we do when we want to clean water, either clean it or desalinate it, we use reverse osmosis. We push it against a membrane. Life does the opposite. It pulls it through this perfectly shaped and charged little pore. Now there's our design challenge. One of the winners was of the Ray of Hope Prize was Aquamidate, a company that is making membranes based on just like aquaporins that are 100 times more permeable than reverse osmosis desalination. So if you look at a world that's going to need clean water, that's a pretty big deal. And it uses a fraction of the energy. And I could go on and on with these. I mean, we're looking now at, we're starting to worry about our health. I mean, COVID has really made us aware we're biological beings. And we also, everybody knows about the antibiotic problem, right? The fact that we use a lot of antibiotics, and that causes super bugs because the bugs kind of hack an immunity to it. There's a tiny, beautiful little red algae and the scientist, Peter Steinberg, found it in Botany Bay, Australia. And he was a marine biologist, and he was swimming around, and he looked down, and there was a lot of biofilms, a lot of bacterial biofilms just coating every surface that he was looking at. And
it's actually red?
Yeah, it's actually red. And then he looked down, and this one plant was sparkling clean, had none of these slimy biofilms, they're called. He took it and he said, what is this? And he went and talked to a bacteria friend of his that studies bacteria. Turns out that plant, that red algae, releases a little substance that doesn't kill bacteria. You don't want them to hack an immunity. But what it does is it just jams their communication signals. So the bacteria passing by, normally what they do is they signal to each other. So a bacteria lands on a plant, signals to other bacteria. The bacteria, and the signal says, come on down, we're going to have a party. We're going to build a biofilm. Bacteria comes down. They build a biofilm. And biofilms are, 80% of human diseases are the infectious diseases have biofilm components. So it's a pretty big deal. Basically, the plant releases something that jams the ears of this bacteria. Not really. It jams as they go by, as the bacteria go by, they sort of get cotton in their ears. They don't hear the party signal, and they keep going. So that doesn't breed for resistance, because you only breed for resistance if you kill you kill 100, and one survives. So it's a completely new way of working with bacteria. So Procter & Gamble, sorry, not Procter & Gamble, their competitor Unilever is making a spray now. And it's not out yet, but they've been working on that, and it's imminent. And that will be like a shield. You'll be able to spray on a surface. Imagine spraying that on a hospital surface. Bacteria won't land. That's, those are big.
Those are big. Those are
Those are
big.
big.
For 100. Okay, so I'm going to stop you there because I know you can go on
Yeah.
forever with these fabulous innovations.
Okay.
But I'm also going to park the corporate involvement in biomimicry because I think that's another discussion. But I want to go back to just what you were like. Are we at a juncture where we know enough to be able to save our planet? Do we need to find more, or are we have what we need to not save our planet? I mean, that's dramatic, but to maybe stop, slow down,
Yeah.
in a way that will rescue, I guess, our
Yeah.
humanity for the next decade or century
Yeah.
or millennia. Are we there?
Yeah.
Do we have enough information?
You know, we understand CO2 chemistry. There's about 6 different pathways. We understand them. That's important. We understand carbon sequestration, which is just carbon being pulled out of the atmosphere by plants and being put in long-term storage in the soil. We understand how that works.
Mhm.
And we're starting to understand that when you have really healthy when you have plant communities that are super healthy, they pull down more carbon.
Yeah.
And now we're learning, like, how can we make our agricultural fields rich in the way, multi-species in the way that these other, wild systems are. So we know enough about ecology and wild systems, and we're starting to learn to mimic those in our settled landscapes, right?
Mhm.
I think that the science shouldn't stop. We have a lot more we could learn. What all biomimicry does is it sort of focuses people on not just learning about the organism, but learning from it, or the
Yeah.
system, and learning from it. There's lots more we could learn. But the answer to climate change is not one solution, right? It's clean energy, and it's carbon sequestration. It's both stopping the emissions and drawing down what's already up there. And do I think that we have the means to do that? I really do. I think we have to put all those technologies, and some of them are things like, there's a project called Project Drawdown, and a really interesting book that looked at 100 solutions and looked at, if we did them all, if we scaled them all up for the next 45 years, and the things that came to the top were things that you might not realize, like they were better refrigerant management. So we're not putting
The boring
HFCs
stuff.
and family planning and women's education,
Right.
because that's, so they're not all technical solutions. They're also cultural. And it's going to be multifaceted. But I do think that, climate change and kind of, marinating in toxic chemicals like we are, and in plastics and all of that, there's the threat to biodiversity. Those are screaming emergencies right now. And they're going to take not just technical solutions, but the willingness of us to reimagine radically the way we live, the way we consume, right? Radically. And so, if you ask me what biomimicry is, I can tell you about a lot of technologies, but ultimately it's about fitting in here. It's a methodology, it's a way that you can find solutions to fitting in here. And that's really what we have to do. It's not so much ending one particular, plague that we've created. It's more, how shall we live here over the long haul? How shall we live here gracefully over the long haul? And there's a whole lot of organisms who have already figured that out.
Yeah.
Yeah.
Well, I mean, it's a mind shift. It's a way, I think I was talking to someone else who's a neuroscientist and an architect, and he's sort of looking at it from sort of the health perspective that, Western medicine kind of through all of our, sense for, we weren't looking at architecture to make us healthy. We were looking at ways to defend ourselves from viruses. We went defensive instead of proactive. And I think biomimicry is kind of, again, bringing nature and human, human sort of, we're just merging those two things together in a way that's more, I guess it's more natural, I guess. But I wanted to just, sorry, I just, that was a bit of a tangent, but I want to go back to what you were talking about, which is corporations that are in some capacity, I don't know in what, in small, large, or not, but like Nike, Procter and Gamble, that are engaged with biomimicry. They are looking at it, using it as part of their research and development. Can you speak to a little bit to that? Is that a new thing? Is that something that's been ongoing? What are the corporations that you would maybe identify as being kind of innovators or pioneers in recognizing that as a discipline?
Yeah. Well, it's now being used in R&D for products, and for processes like improving manufacturing processes. And so this idea that you would have a biologist at the design table, it is becoming accepted. So when you talk about, like, for instance, Unilever, they heard about this project and they said, yeah, that's a completely new way to look at antibacterials. And they actually created a whole company within their company to work on it, and that's a pretty big commitment. That's the big commitment.
Yeah.
But they're also, so there's product design. But then the other thing that's happening, we've worked with about 200 people over the years. It happens. We often can't talk about it. They see it as a competitive advantage. But the thing that I'm really excited about right now that ties to architecture is applying biomimicry to place. And what I mean by that is that some of the biggest impacts that these corporations have are the lands they touch. So in other words, those lands might be their corporate headquarters, their corporate campuses, their manufacturing plants. But then when you go beyond that, there's other lands they touch, all of their supply chain lands, all the farms where they get all their ingredients from, the forestry where they get their packaging from, the fisheries. And so what we're doing now, we have something called Project Positive, and it's a learning cohort of Ford Motor Company, Microsoft, Google, Interface, Aquafil, Kohler, and several others. And what we're doing is we start with a place like their corporate campus. We go in and we measure, we look at what would be there if the corporate campus wasn't there. I mean, now it's like parking lots and usually turf, right? And buildings. We say, well, if we weren't here, it would be this kind of forest or this kind of meadow or this kind of prairie or this kind of wetland. And then we find a reference habitat. We walk into that reference habitat and we say, what are all the services, ecosystem services? They're things that nature does for us humans, right? They're things, what are those services? And we measure them in that place per hectare. So we say, how much air is this forest cleaning? How much soil is it building? How much nutrients are it cycling? How much habitat is it, what kind of habitat support? How much carbon is it sequestering, right? How much cooling is happening? And we literally get metrics.
Wow.
We go over then to their corporate campus, and we do the same measurement. And we say, okay, here's your current performance in terms of 20 ecosystem services that the UN recognizes. And then here's your ecological performance. It's always been, it's much, the forest is doing much better than our sad little parking lots, for sure. And then we try to close that performance gap. So say the service is water storage, right? So instead of having the parking lot, we might replace that with permeable pavement. So you're actually storing water, or you're storing water on a green roof, or you've got bioswales now as in between the parking areas, right? So you're measuring that ecosystem service. But where the real flip is that, and this is, we're so tuned to sort of reducing all the bad things we do, and it's called net zero, getting to zero bad things, right? This is called Project Positive because what you're counting is what and give away. How much clean air does it send to the neighbors next door? That's what ecosystems do, right? They're generous. So we call it generous design. So, and it's biomimicry because it's nature as measure. We get those metrics and we say, per hectare, here's how much water you have to store this year. If you want to be performing or mimicking, emulating, performing like that ecosystem next door. And they say, and it changes design, completely changes design. And so, then we say, well, what about your supply chain? Can we go to the ag fields and do the same thing? And can we go to your employees' backyards? Can we go to the school yards? Whatever land you touch, you can heal. And you can send out positive. And that's so unusual, Catherine, for human beings to, in this day and age, to say, how beneficial can we be? And make that aspirational goal. That's biomimicry at a systems level. And boy, corporations are so excited about it.
Yeah.
So yeah. And that's surprising. You asked what changed. That's surprising to me.
I would say that would be a change. I would think that they would look at that from a non revenue line sort of perspective, but more of a looking at it for sort of the holistic value of the company, right? Not from does this make economic sense? They're doing it more from
when I've asked I've asked corporations, who are in the Project Positive cohort, and they say, society, we have a license to operate, a societal license to operate. That's their terminology. And that means society allows you to operate. And so this idea that you're giving beneficial, that it's not NIMBY, that's not in my backyard, but it's PIMBY, it's please in my backyard. That reduces their risk. If you talk about, Microsoft and building data centers somewhere, if a data center is actually going to help regenerate a landscape, because the buildings, it's not just that we're planting trees, the buildings also have to pull their weight. So if you can imagine that the building has a healing effect, not just on its land, but on the neighbors around it, that social license to operate. And they say, we now are in a place where corporations need to show that what they're doing for the community. And the civic gesture used to be a museum or a stadium that the corporation would build. And I would suggest it's a healthy bioregion now. It's a healthy watershed.
Yeah.
It's, can you clean up this watershed? Now, it's not happening everywhere because it's brand new. This design, we call it design for ecosystem services, right? And we're so, well, if you're going to build a highway with the infrastructure funds that are someday going to happen, rain down here in our world, hopefully. can you build a can you build a highway that whose easement, is storing water and allowing pollinators, supporting pollinators and supporting wildlife migration? How many ecosystem services can you pack into
Mhm.
your infrastructure project, right? So that's called design for ecosystem services.
Nice.
And it's very cool. It's very, very, very cool. Yeah.
Yeah.
And architects have always been, the people in the built world have always been the first early adopters of biomimicry.
They have, but they're part of a sort of a corporate business model too. So I don't think they've gone as far as they could. I think there are exceptions where they've been sort of, but I look at all the condominiums in our city in Toronto that are going up, and they're completely removed from anything that seems sustainable. So, and that
Much less beneficial, right? Much less positive.
Mentally, nature-wise, anything, right? So, we have a long way still to go. I love your optimism. I was going to ask you, you're an optimist and pessimist. I don't have to ask that question because I can see you're an optimist. But I wanted to ask what's the question? I've gotten looking at my list of questions here. It's biomimicry is kind of still under the radar. It's not a word that comes up in conversation the way other things do. So, like you mentioned, Procter, was it Unilever? Like, how come we haven't, like, this hasn't sort of become a selling point or for people who would be watching videos on Planet in Focus? Why don't we know who is working in this area and who isn't?
Yeah, I think we're still looking for our hero case study, frankly.
Yeah.
I mean, people know Velcro, right? The story of Velcro is a guy was walking his dog and the burrs were on his right? The Swiss scientist anyway, and he mimicked those burrs, and that's Velcro. Everybody knows that story. There are so many biomimicry products that are out and about, but they don't. And part of writing the book for me was to give it language to you know what I mean? So we could point to it and go, but I don't think it's a household word because I don't think we have that household case study. And that's why it's really important. That's why in our nonprofit, one of the things we do is we're trying to democratize biomimicry so everybody can have the tools, right? That's asknature.org. That's our, go check that out. It's where you can find biological solutions by typing in, how does nature filter salt out of water? But we also do design challenges because we want to, show the world, and we do a lot of promotion of those companies because it's happening. But it does need it. I think it needs that visibility that comes with, we used to call it the Oprah moment.
It needs a book club Oprah moment. Yeah,
it does, doesn't it? Yeah. And believe me, if you figure that out, Catherine, let me know.
Oh,
I'm kind of searching.
Maybe we'll do this interview. I don't know. I don't think so, but maybe, you never know. It can sometimes come in unexpected ways, but I do think that, as soon as you understand the concept, it's almost so evident. As you said, what did you describe yourself as? The woman of the obvious?
Queen of the obvious.
Yeah.
Queen of the obvious.
Once it's there. Maybe it's just so obvious people, I don't know. But is there a way, I think you're right that, it's also a process of it's sort of surfacing in a collective way, and then it will just kind of flip over at one point. And maybe we're getting close to that a moment because of, as you say, climate change is right at our doorsteps, ageism and, densification, populations and all of that starting to really become critical to kind of the health of the earth, and so people are becoming sensitive to it and aware of it and activated by that. Now, is there, I read an article recently about sort of, is there greenwashing in biomimicry? And the article I read was kind of a one that maybe people will recall, which was, I think it was the Olympics. It may have been, I've lost track of time now, but 2 summers ago or 3 summers ago, when the swimmers all suddenly were getting golds, and they said it's because of this swimsuit that is a biomimicry of shark skin, which gave it this extra lack of friction that allowed them to cross the finish line ahead of time. But in fact, that wasn't the truth. It was actually that the swimsuits were just much tighter to their bodies.
Right. Yeah, it was. There was an Olympics where they were using the shark skin suits. There was an Olympics, and it was technical doping, but it was also because it was tighter to their. But it's been banned. I mean, the shark skin has been banned. The shark skin suits.
And so it wasn't, in fact, a biomimic.
It was several Olympics ago.
Okay.
It was Speedo. Speedo studied sharks. They had skin that they got from, zoos, and they mimicked it. And so and now you're not allowed to have that shark skin anymore.
Yeah. Okay, that's interesting. I thought that was, I wasn't sure which there was truth or.
Yeah.
So what in your, if you can sort of point to the best examples of biomimicry, what would you say were sort of the ones that really stand out as being really sort of seminal in changing how something was conceptualized, like aerodynamics or whatever? What would you describe as being,
anytime. I mean, the aeronautics field is no stranger to biomimicry at all. Those little wing things that you see, they're like those little wing tips on the end of, the end of planes' wings. Those are from eagles, right? And the nose cone, when you walk by that nose cone and you see that kind of spiral thing, that's mimicking the peregrine falcon's nostril, believe it or not, because they come down at about 200 miles an hour.
Wow.
And that's a lot of air in your nostrils. And same way with a plane, they don't want all that air forced into, they want to control the air that goes in. So that is in fact, if you go to an airport, like you've got that, you're looking at a lot of things in the plane. You also, as you go by those millimeter wave detectors, that you do this, that's an acoustic camera in there that's based on the echolocation of the Brazilian free-tailed bat. And then if you walk along and you see everybody holding their phones and talking, the chip in your phone, the microphone, there used to be just one microphone, one microphone. And now there are, like your ears, there are 2 in most phones. It's a company called, it's a technology called EarSmart from a company named Audience. And Lloyd Watts studied the human brain, and because they were looking for noise canceling, they were looking to make your calls clearer, right?
Mm-hmm.
And so what he did was he studied how, if you and I are at a cocktail party and there's all that noise, how do I focus on just your voice? And he reverse engineered the neural network that does that and put it into software. And there's a chip in most of our phones. So people do not realize that biomimicry is everywhere. One of the things that I'm watching, because I track this like a horse race, all these biomimetic technologies. The coronavirus. There's a small group of scientists in a consortium that are doing the most biomimetic thing that we can do about COVID, which is study the bats who for millions of years have been living with coronaviruses and
Really?
emulate, because and I'm looking, and maybe that's going to be that case study that bubbles to the top, because bats, you know how it jumped from bats to us, right? Now, bats are living with it. Why aren't they dying? Why aren't they like falling out of the sky? One of the reasons is that their immune system, you know how our immune system just goes crazy and sort of overreacts to the virus, right? To COVID. Theirs doesn't. So there's these scientists, not as many as you'd think. I would think we would have a huge worldwide effort into this. Are saying to the bats, this is the biomimicry question, how are you doing what I'm trying to do? How are you controlling your immune system so that it doesn't, how are you living with the virus? Because I have a feeling we're going to be living with these viruses.
Absolutely.
So that, you know, perhaps that will be the case. Perhaps that will be the case study, you know, but you're already living with biomimetic technologies. What's that?
Sorry, I just said that sounds, I would bet on that, because that sounds like, you know, but again, it's funny how there is still a disconnect people have between, you know, that reality science and then the application of it, and that, you know, we should look at science more carefully. But I mean, that's an interesting, I didn't know that about bats. I didn't realize that you're right, they have been surviving and living without any effect from this virus that's taking us down as a society. So that's
the question, I mean, I'd have for you, because every time I tell people what I just told you, they have a duh moment, you know, like, wow, of course, why aren't we studying those? So my work for the last 24 years has been to have people have it be the first thing they think of is what in the rest of the natural world has done it. Why do you think it is something that eluded us? Like, why wasn't that the first? What do you think it is about us as human inventors that we didn't think, like, let's go to the bats?
That's like a $1 billion question. If I could answer that, I would be a millionaire. Right? I would be Bill Gates or something. I don't know. I mean, it confounds me as much as it does you. I mean, how, you know, sometimes the most obvious thing is the hardest thing to you know, for people to see. I don't know. I can't, sorry. I'd love to say this would solve it, but it's I think for me, biomimicry, like I'm trying to like trace back my slow sort of learning of that over the course of 20 years. And I think, you know, it does require a collective consciousness. It's one of those things that requires everyone to feel that's the right trend to follow. So, you know, and you know, we're getting there. I think I'm an optimist as you are. I'm half full. I think, you know, the next generation is going to embrace climate change and find you know, really take it on as their cause. And you know, we left them a mess. They're going to fix it, and it's going to become cool, whatever that word means on the scale of, you know, fashion versus just, you know, rightness of activism. I think I'm an optimist. I think that it has reached a critical point, and these things will begin to get picked up. So while you know, your examples of the bats and the algae, the red algae, that's going to become the default, but it's not going to happen and maybe it's a good thing. It's going to be a gradual evolution, not an overnight one. So maybe we're like, I don't think there's going to be a eureka moment. I don't think people are going to go, oh my God, environmentalism, biomimicry, I'm on. Like, I think we're moving toward that. I think it's a generational thing too.
I agree. I know that it has something to do with humility. Because Well, yeah, I mean, and hubris. I mean, the fact that we don't look at the bat that's been living with it is hubris. Like we're like, we'll figure this out. Like we have that hero inventor
yes,
complex, right? Like, and we're not
top of the
we're not
pyramid
humble
thing.
enough, but we're becoming humble. Yeah, we're becoming humbled by seeing our growing shadow on the cave wall, like, wow, we're in, right?
Yeah.
We're becoming humbled. The sirens are wailing. And maybe
Good
that's
point.
what it takes to say, for an engineer to say, I might learn from an octopus. It might be my greatest teacher, right? And then I think it'll, critical mass of people inventing in this way. I mean, one of the jobs that we've tried to do at the Center for Biomimicry and our institute is to make this second nature, help people in the design professions always reach for help first from the natural world. And that at some point, I think you'd be seen as foolish if you didn't do that in your design protocol, right?
Exactly.
Like it would be like, why didn't you? You mean you didn't go to the back? You're right. It's gradual for us. My Bill McDonough says, it took us 400 years to put wheels on our luggage. So just when you think you're really brilliant, we.
I think we started with 2 and then we figured out 4.
So,
like it took us even, you're right. The luggage analogy is perfect. It does take some time for us to get
some people get it. Who, and I realize now you're sitting in Toronto, who got this, the very first person who ever had me speak. And I was like, I don't speak. I'm a writer. You know who it was? Jane Jacobs.
Of course.
Jane Jacobs called me up. She Mary Rowe, who was running the Ideas That Matter conference, which was a 5-day conference. And Jane Jacobs got to just pick ideas she liked. And she was writing The Nature of Economies. And she read my book. And so I got a call with a fast Canadian voice, and it was Mary Rowe. And Mary said, do you know who Jane Jacobs is? And strangely enough, because I was a young, when I was a young writer learning how to write, Jane Jacobs' Death and Life of Great American Cities, I had no interest in urban planning at all. I was a writer and a biologist. She taught me how to write. I thought she was the best essayist I had ever known. And I also thought she had passed. So when Mary Rowe said that, I thought it was like a radio show, and they were asking me, I said, the Jane Jacobs? And she said, yeah. And I said, well, and then Mary Rowe said, please hold for her. And I was on the phone, and Jane Jacobs is on the phone. And like my hero. And she says, she said, Janine? And I said, Jane? And she said, I can't believe I'm talking to you. And then I said, like, the most elegant thing that I could think of, which was, we'll double here. I said to her, and she said, would you come and speak at a conference that I'm having? And I was just like, yes, anything, but I don't do that. I've never done that in my life. But tell me where to be and I will be there. And it turned out I was the opening keynote, which she neglected to tell me. So Jane Jacobs found biomimicry, and it was 1997. She found it when it first came out because because she's brilliant, and she read outside of her field. She read all around her field, and there are people who get biomimicry instantly, like Jane did.
Yeah.
It's not everybody yet, but she was the first person, and boy, did she expose a lot of people to it at that conference.
Beautiful story.
It was incredible. Yeah. Oh, and then she became a mentor of mine. She'd call me up every now and then, go, I know you're a writer. And you don't want to go out and do speaking, but you got to do both. You got to get out there. And I know you don't like it. I don't like it. You have to do it. It's important. Yeah.
Wow.
Yeah. She was a
Wow.
mentor to me, the very
Well,
first person.
yeah, she lived in Toronto for I don't know how long, but a significant amount of her time, her
Oh,
life was here.
yeah.
She had
Yeah.
incredible influence as well here as she did in New York. Yeah, I would remember that. I would be thrilled if she called me to as you were. So tell us about, I'm going to wrap up because we're kind of coming up to the end of our hour. You've written 6 books and now you're on your 7th. What is there to say about my biomimicry in 2021?
So my other books were about plant and animal adaptations. And then I wrote about people studying those adaptations in biomimicry. And now what I've realized is that one of the things biomimics need is to understand the biology. They need to know the design principles that they can then turn into, into products and processes and systems. And they're not biologists. So one of the biggest hurdles is getting the biology synthesized and just sort of crystallized into design principles. So I'm writing, and what's most interesting to me is nature's universals. And what I mean by that is there's a lot of diversity in the natural world, incredible diversity, but there's also things that all organisms have in common. And those are universals. And I find that really interesting. So I'm ready. So the chapters in this new book are things like, how does nature heal from trauma? And I'm looking at healing from, you cut your skin and you heal, all the way to Mount St. Helens. How did it heal after the volcano went off? How did that ecosystem come back? I'm looking at, are there biological principles that run across that whole thing? So it's really fun. And how does nature shape and create community? Why are mutualisms and cooperation so ubiquitous in the natural world? And are there anything that, no matter whether you're a bacteria, a fungus, or a zebra, it works in the same way? What about chemistries, like the circular chemistry? Everybody's looking into circular economy right now. That comes down to chemistry. Can you have a product that, can break down and that set of materials can be used again and again and again? And it turns out that building block, that Lego set, is now, we're starting to understand the unity in all that biochemistry, and and can we mimic that? So I'm looking, it's interesting. How does nature, how is nature generous? The chapter about these ecosystem services, how do those systems continually give away more than they take? How do they continually do that? Anyway, so yeah, the new book's about hopefully it's going to be a source book for biomimics and just the biology. I'll read. I've been reading, like, I'm on sabbatical now. I've been just reading, like, I have 23,000 papers I'm moving through right now. So I'll filter feed for you. I'll masticate it. I'll digest it for you, and then
what is the book called? What is the book called, and when can we see it? When will it be available?
Next year is the writing year. I'm done with the reading, and I think it's going to be late 22 or 23, and I don't know what it's going to be called. It's just the code name is Nature's Universals. That's at the center of my giant mind map right now.
Yeah.
So I don't know.
Wow.
I don't know. I usually let the publishers help me with that one.
It sounds amazing. Yeah. Janine, it's been awesome speaking to you. Congratulations being the eco hero of Planet in Focus. And I hope someday we will meet in person in Toronto when COVID's long gone. Thank
be
you so
great.
much for your time. I really appreciate it. And let's stay in touch.
No problem. No problem. I enjoyed it, Catherine.
Yeah.
You're a good interviewer. Thank you.
Oh,
Thank you. You made it easy.
Okay.
Yeah.
Thank you very much.
All
Have a good
right.
night. Bye.
Have a really